Hello everyone. Thank you so much for coming in today. This is my first talk at a conference and that makes it really special. So today I'm going to be talking about spatial thinking with Python. So as you can guess from the name, it's about geospatial data. And a quick introduction about me. My name is Sangarshanan and it's really cool to, look at people try to pronounce my name. It's really hard. My dad can pronounce my name too. And I recently graduated from BIT Vellore just last month. And since then, I've been working at Grofers, which is based out of India. It's a grocery delivery application. And I like to make memes while hanging upside down. It's a millennial thing. Yeah. So this presentation is going to be filled with a bunch of memes. Hope you guys are cool with that. So, geospatial data. First I'm going to start with the story. So the year is 1854 and the hero of our story is Jon Snow, a real name by the way. Yeah, he was also called the king in the north, I don't know how. But this guy was about to change the world forever with a map. And the year was 1854. I think I told that. Yeah, so in 1850s, cholera was widespread in London and people did not know how it was spreading. People thought it was miasma. This is how they thought even the Black Plague was spreading. They did not know exactly the reason for it. And a lot of people were dying because of this. At that time, what Jon Snow did was, he collected the data of each and every patient who had died and he plotted them on a map. Pretty basic, but nobody has ever done something like that before. And the map looks something like this. All the cases of cholera were centered around a pump in Broad Street. So he was able to deduce that it was waterborne and it was caused because of this pump, which essentially actually cued the epidemic. So what Jon Snow did in 1854 was called Locational Intelligence, which is making use of your spatial data to make intelligent decisions. It's pretty cool. And also, have any of you guys ever worked with geospatial data? Oh, wow, awesome. But I have seen, when I go to meetups and conferences, I've seen people not paying a lot of attention to geospatial data. It does not get as much attention as text data or image data gets, and that makes Thanos really mad, and we don't want him mad. So let's just jump into it and talk about the real basics of geospatial data. So the first question we ask ourselves is, what is geospatial data? So you can Google it, you can get tons of definitions, but in the end, geospatial data is something that can be layered on top of a map, or something that essentially has a geographic component to it. And what are these geographic components? There are two types of geospatial data. One is vector data, and the other is raster data. And we'll talk more about them. First, raster data. Raster data is just a bunch of images, and images are made up of pixels. Raster data is made up of regularly sized pixels, and it is good for showing varying information, and also it occupies a lot of space since it's an image. Raster data is made up of bands. So what essentially bands are is, if you look at images, they are made up of they're essentially a result of their wavelength and their resolution. It depends on how the picture was taken. So there can be red, green, and blue bands, and also sometimes it can have spatial metadata, like the elevation of a particular pixel can be encoded within the image, so that, for example, you see topographic images. Based on the image, you can see how elevated a particular region is, and also sometimes they show snow on top of it, so that you see how elevated that is. And also there are multispectral images which have more than red, blue, and green bands, something like IR bands. So this is essentially used to find something called NDVI, which is Normalized Difference Vegetation Index, which is used to calculate how green a particular area is. So for example, you see an image and you take the wavelength of the red band and the IR band, and you use a formula to calculate about how green a particular region is. Yeah, cool. And now we know what raster data essentially is. We can see how it's being used. So right now, we all know the Amazon rainforests were on fire recently, right? That is pretty sad. But people are able to monitor what is happening over there, and maybe even assess the damage and mitigate it by using raster data or satellite images essentially. Apart from being used for this, raster data can also be used to predict natural phenomena, like predict tsunamis, predict earthquakes, even before they happen. And also, it can also be able to find the degree of urbanization of a particular region based on the road network. We can also find the affluence index of a particular region based on the amount of activity we see at night. So that's called night lights. All right, now to vector data. Vector data is essentially a bunch of latitudes and longitudes. These lat longs can combine together to form shapes. These shapes can be a line, a polygon, a circle, absolutely anything. And these bunch of lat longs can be represented using something called a well-known text. Well-known text is actually approved by the Open Geospatial Consortium. And also, there is something called well-known binary, which is used to store these geometries in databases. And now you know these geometries exist. Now you want to project them onto a map. So for that, there is something called SRID, which is the Spatial Reference System. So it tells us how we project our data onto a map. So essentially, there are two different kinds of spatial reference system. One is the geographic coordinate system, and another is the projected coordinate system. So first, what is GCS? GCS is what we use in our GPS data, which is essentially lat longs, right? So we have a prime meridian as a center, which divides the Earth into latitudes and longitudes, and we use that to find our point. And there is also another type, which is projected coordinate system. It's something like an orange, where the Earth is round, and you peel it off, and you place it, and you project it out. So it's just a bunch of trigonometric functions which can be used to represent the point. Oh, yeah. And also, GIS data has tons of different formats. Vector and raster data can be a GeoJSON, a KML, a GPX, a CSV, a shapefile, literally a lot of them. But now you need a way to read and write them using Python. So now we come to the juicy part, the packages and the libraries which exist to do that for us. So there are, a lot of geospatial libraries which are present right now, and it's actually really confusing for someone who is new to the help. So the mother package, or what essentially all geospatial software and packages use under the hood, is GDAL and OGR. Which was written in the year 1998, the same as me. And it supports 154 raster and 93 vector geospatial formats, which is actually a lot. GDAL can be used to read, write, analyze, and translate geospatial data. It also has a command line interface, and which can be used to do the same. So now, GDAL and OGR also has bindings in Python. Yay, but it's very unPythonic in nature. So that is why people have written packages or wrappers around them that makes it easier for Python users to work with geospatial data. So the raster data, so essentially it has 4 different APIs. One is the raster API, which is GDAL, and another is OSR, which is for spatial reference systems, which we talked about. And then GNM, which is for network data, which is essentially the road network data. And then Vector Data API, which is OGR. So these wrappers around all these APIs are written in Python, which makes our life easier. Now for vector data, essentially the main package written over OGR is something called Fiona. Fiona calls themselves OGR's neat and nimble API for Python programmers, and they really are. It provides a very Pythonic interface to read, write, and analyze geospatial vector data. And also now, we know vector data is made up of geometries. To work with these geometries, GEOS, or Geometry Engine Open Source, offers us a thing which is, Shapely also has a wrapper around that, which can be used to work with geometries. Now we can read, write vector data with Fiona, and vector data is made up of geometries. We can work with these geometries using Shapely. And now as we all like pandas very much, there is also GeoPandas, which wraps up what Fiona and Shapely does as a pandas data frame. And OSR projections. So for to project your data spatially, there are two different packages. One is PyProj and another is R-Tree. So R-Tree can be used to index your geospatial data. So indexing geospatial data. So we all know that indexing data is really important because it makes our queries really, really fast. But how do we index geospatial data? So one of the most important data structures which we use to index this is something called an R-Tree. And R-Tree is, can be considered as a multi-dimensional version of a B-tree. So there is an initial, so this is just a bunch of points. I'm going to explain how R-Tree works. But even though indexing has an initial cost, our search queries run much faster, and the initial cost is actually worth it. So right now we have just a bunch of points, and now we divide these points into minimum bounding boxes, where we divide it into equally spaced points. Now we repeat that again and again till we have a bunch of points inside boxes. So as a rule of thumb, higher value means faster indexing and slower queries. So, and also a blog by Mapbox says that we should keep that value around 9. Now, this is how R-trees look like, essentially, where you divide your entire space into a bunch of different minimum bounding boxes and have a tree structure. So this is really useful when you want to learn stuff, like finding out the number of hotels in a 5-kilometer radius. Your queries run really faster because your data is already indexed in a very beautiful way. And now there is also a way where you can also work with your data where you can index it with respect to both space and with respect to time, which is something called spatio-temporal indexing. So there are projects like GeoMesa which actually do that, which is really cool. And also in databases like PostGIS, you can write geospatial queries on indexed data, which makes the queries a lot faster than writing it in Python. So this is something wherein you don't have to loop through all your data, and it's already indexed, so the results are pretty fast. So this query is what Commissioner Gordon uses to find out whether Batman is in the city or not, so that he doesn't get ghosted. And also Uber has their own geospatial indexing, which is called H3 grids, where they have divided the entire world into hexagonal grids. And also there is something called quad trees and also S2. If you want, you can check that out too. Coming to raster data, the most important package which is used for working with raster data is raster.io, which is a wrapper written around GDAL. It provides a Python API based on n-dimensional arrays. So we can perform a lot of operations using raster.io on image data, something like masking, warping, clipping, stuff like that, and also find out the normalized difference vegetation index using raster.io. Now, we looked at all the packages which can be used to work with geospatial data. There are also packages which are written over these packages which are already wrappers on other packages. So those exist too. Something like EarthPy. EarthPy combines GeoPandas and raster.io to provide support for both vector data and raster data. And also this really, really cool package which I absolutely love, which is called OSMNX. So what this essentially does is it takes OSM road network data and converts it into a graph, which is essentially a bunch of nodes and edges. And we can use Network X to do anything we want, literally. Since it's just a graph, we can run pathfinding algorithms, optimizations, everything. Now to visualize geospatial data. Visualizing geospatial data is the most important part of this talk, actually, because it's easy to tell stories with incredibly looking maps. And you can tell better stories with data. And if you had looked at a show called Patriot Act on Netflix, actually these guys won an Emmy for actually telling good stories with maps. And now you must all think that to create such cool maps, you must know JavaScript, right? Well, yes, but actually no. There are major libraries which are written over JavaScript packages, sort of like Leaflet. There are wrappers written over them called Folium and IPyLeaflet, which can be used to visualize maps on Python. Also, you can go easy and use Matplotlib. So Matplotlib has a package called Descartes, which enables plotting of shapes as a Matplotlib plot. And also, this is how Folium has written a wrapper over Leaflet. Yeah, and this is how the map looks. And also, we can use Mapbox, and Plotly has support for Mapbox-based maps, wherein you can also use that to plot. And also, I have attached a code for all of this at the end of the slide, which you can check it out if you want. Now, coming to spatial data science. So data science is the hot topic nowadays, and TensorFlow 2.0 is pretty cool. So any data science topic, you take it and just add spatial on top of it that exists. Something like constraint clustering, add spatial to it, spatially constrained clustering. Regression, spatial regression. Data analysis, spatial data analysis, just add spatial to it and it's there. I don't know how. But there are actually cool algorithms like k-means and dbscan, which is k-means is a distance-based clustering. With dbscan, you can have density-based clustering. And these, you can also have constraints where you can cluster based on the population, based on the affluence, based on the area code, based on the pin code, anything which you want. And also spatio-temporal analysis, which is really cool. How cool would it be to predict something with respect to both space and time? This is exactly what we can do with spatio-temporal data. And now, actually, I had a coding demo, which I'm not going to be doing because of time constraints. But I will share the GitHub repo with you guys if you want to check out the code for all of this. But what is the point of all of this? Because what kind of impact does geospatial data actually create, right? So before that, we saw tons of problems wherein we can predict natural disasters, we can calculate the vegetation index, but that does not help us, right? That's something people in NGOs do. But what do we do? Marketing. Marketing is something that all of us are familiar with. Now just add geo to it. Geo-marketing, there you go. Now, you can cluster customers with respect to spatial constraints and their behavior. So for example, you have customers living in a particular area. Who are your target customers? You can find areas similar to that area and target customers in there. That may be your use case. But there is also a very controversial blog on this, which says that your app knows where you were last night and they are not keeping it a secret. For example, Uber essentially knows where you go to work, where you live, where you go on a daily basis, and they can say where you're going to go tomorrow. But and also geospatial data, location targeted advertising is a $21 billion industry, and people are taking advantage of your location data. So always switch off your location whenever you can. And also Burger King has done something really cool with spatial data. If you have seen the ads recently, if you are near a McDonald's, they offer you a Whopper for a penny, which is pretty cool. This is something called geofencing, wherein if you are in a particular fenced location, you get targeted as a customer. And also, this is something we all collectively hate, geo-search, Uber's search pricing model. So what Uber actually does, which is something really cool, wherein they calculate your geographic locations, look at the traffic, look at the weather, and essentially increase or decrease your price based on demand and other geographic factors. And not only these, there are also tons of companies which leverage their geospatial data and do tons of cool stuff. For example, Starbucks. Starbucks decides where they're going to open a new outlet based on the areas in which their existing outlets perform. And also, this is also done by other companies like Wendy's. And also, there are companies like MasterCard, which predicts fraud depending on your geographic location. For example, you've been in Europe for the past month, and suddenly there's a transaction happening in the US. It detects that there is something wrong going on here. And also Airbnb. Airbnb has something called a location relevance model, wherein based on where you search for a house, your query results differ. And there are like tons of use cases apart from this. for geospatial data, when we use it right, we can make really good progress. And also, these are some of the blogs I stole from or borrowed indefinitely. You guys can check those out. And you're all breathtaking. Thank you very much.
Sang, we still have 5 minutes, so if anyone has a question, we can use that time. Anybody have any questions? We got one down here.
Thank you. So a question on real-time data. Are there any libraries in Python where you could plot real-time geolocation information? Do you happen to know?
Yeah. So you can use Folium itself or any wrappers around Leaflet to plot data in real time. There is actually a plugin for in Leaflet to plot real-time data. I could show that to you. I don't know the name of it, but it's called folium.realtime layer, where you have a real-time layer and it keeps refreshing, I think. And you can also set the time by which it should refresh every 3 seconds or 5 seconds. I hope that answers your question.
In terms of futuristic applications, what type of geospatial applications would you like to see come to fruition?
I did not understand the question, I'm sorry.
So if there was a geospatial application that you would like to have, what would it be? Like something new or something unique, something you want to see done?
That is a very deep question. So one thing I'm really interested in the geospatial realm is gentrification. Right? We all know that it's happening wherein areas are getting urbanized, and our homes, essentially where we live, is changing very rapidly. So based on actually satellite data, we can actually predict the extent of urbanization or how rapidly an area is changing or getting gentrified based on the satellite images we get, the motions we see at night. So that is something I'm really excited about. I'm planning to work on it to see with respect to time how an area has progressed, how it has moved through time spatially.
Hi. You quickly mentioned predictions on spatial temporal variables. Was that covered in the blogs that you showed, or do you have any additional examples of that?
Working with spatial temporal data.
Prediction of using spatial temporal data.
Oh, do you mean do you have an working example for it?
Yeah, are those covered in the blog links that you provided?
No, it is not. So, for example, right, for any supply chain company, for example, I work in a company called Grofers. So we essentially have a supply chain, and we actually have customers ordering from different locations at different times. We have a problem statement where we need to predict where an order is going to come from and when it's going to come. So this is essentially a spatio-temporal prediction problem where you have to predict where an order is going to come with respect to both space and time. So that can be one problem statement, or there can be multiple.
Thanks.
We got one more in the front. Two more, actually.
So you mentioned the Uber hexagonal
H3 grids.
hex, yeah. So I was wondering, so obviously that kind of gives you kind of like a understanding of how distances as the crow flies in a way. So like just straight point A to point B. I was wondering if you knew of any ways to handle geospatial issues regarding how the how the road infrastructure affects what's closer. Because for instance, if you're on the wrong side of a one-way street, you might have to double back a bit more.
Yeah. So I think I told about a package called OSMNX, right? Where you convert your road data into graphs. So in those graphs, you can have factors wherein you can go only on we can traverse only one side of the graph. You cannot traverse on both sides, which essentially means that it's a one-way. There can also be factors like weights on a graph, which says about the traffic on a particular road, so that those factors can be taken into account while you're calculating your path or your route for essentially from point A to point B. Does that help?
Hi, I had a question. I used to do like GIS type stuff back, but not really. And most of it usually was like PostGIS, and I still find PostGIS super really like unfriendly.
Yeah.
Is there any friendlier ways to kind of do like Python and geospatial to get together like that aren't reliant completely on PostGIS, or like better ways? Because I feel like it's always like very unfriendly.
Oh, you think PostGIS is really unfriendly for writing?
Yes, kind of. Like there's a lot of extensions and like functions that like it's really hard to like kind of do unless you really have mastery of SQL and also like PostGIS extensions and also like so like I feel like
So have you tried using GeoPandas?
no.
So you can query your data out of PostGIS into a data frame using GeoPandas, and essentially it gives you a data frame, and you can do anything you want in Python with the data frame.
Cool. Awesome. Thank you.
Any other questions? Okay, well, let's get a round of applause for our wonderful speaker.